So I believe we last left off on uncertainty. Did we talk about uncertainty? Exact numbers?
Yes.
Yes. Okay, so that's good to know. I'm not totally off today. Okay, so how do we deal with uncertainty, right? So we have numbers that we know that are going to be exact. Like we know that 1 foot is going to equal 12 inches. And now you should know that 1 inch is exactly 2.54 centimeters. And we know that 1 gram is exactly 0.001 kilograms. Those are exact numbers. So what do we do when we are not sure how exact things are? Let me give you an example, because I know it's still early and your coffee hasn't kicked in yet and your hair is all up like this. I'm not trying to call you out, Cassie. So how many of you guys have a scale at home?
Me.
None of the rest of you guys do. Don't lie, because we all are pretty vain, you know.
I do have a scale at home.
You do have a scale at home, right? And
yes.
So you guys all have pretty much have a scale at home, even though there are only 3 of you guys admit to it, right? We know that we're pretty vain, and I'm pretty sure that most of you guys have a scale at home. And I know that you guys step on that scale, right? You guys step on that scale?
Yes.
Yes. Okay, that's good to know. I'm not the only one. So I got the scale that I bought at the flea market, right? Because I try to save money where I can. And the flea market is a great place to get something that you know you're going to use, right? That may just be old and somebody wants to get rid of. And a scale is just like that. So I bought this really cool looking scales, glass and everything like that. And then I get on it. And I told you guys how much I weigh. I tell you guys 220, right?
Yeah.
When I get on that scale, it'll be 225. You know, and I'm like, hey, wait a minute. The other day, it was 218, right? So I get back on it. Oh, now it says it's 221. Then it says it's 223. Is my scale exact?
No.
No.
Yeah, if I went to Cassie's house and I got on Cassie's scale, it'll probably say like 225, right? Or 228, okay? Because we know that we have instruments, and those instruments are not always going to be exact. They're going to have some fluctuation. Is that uncertainty?
Yes.
Yeah, it's uncertainty. So how do we account for that uncertainty?
Did we go with a mid number? Or like a number in between?
We'll just pick a number in between. Oh, that sounds good. Yeah, that's the one. Oh, no, not that one. It'll be this one, right? 223.
Yeah.
Does that alleviate the uncertainty?
No.
No.
No, it doesn't really. So that's why they developed significant figures. That was the real reason why it was developed. And I'll show you another way that we take care of uncertainty here in a second. But this is how initially it started, because we have instruments that we use on a daily, and there's some uncertainty associated with it. Some of our instruments are a little more exact than others, and some of them are really crappy than others, okay? So under these circumstances, we start using what we call Sig Figs, trying to determine whether a number is significant. So I tell you how much I weigh. How much do I tell you I weigh?
220.
I say 220, right?
But in the scale, it says 225.
Well, no, the scale gave me 3 different numbers. And the week before, it gave me 218. So don't insult me. Hey, are you calling me fat? I see how it is. Right? The other day, I said it was 218. So what I said 220. Because I know that this last number here is going to be fluctuating. Right? It's not exact. It's not sure. It's my uncertainty. Right? But I know that this number here is going to be pretty much consistent, because if I take a look at 218, I can round that up to 220, right? This guy, 223, right? I can round that down to 220 because that number here is not greater than 5. This one here, guess what? 220. And then this number here, because there's not a 0.1 afterwards, I can still say 220. And so I feel comfortable saying, how much do you weigh? I weigh 220. You guys see that?
Yes.
So
Yeah.
that tells me there that I have two numbers that are significant. And this last number, it's kind of questionable. That's my uncertainty. So by me writing just 220, it lets me know that this number here in the one spot, that's going to be my uncertainty. You guys get that?
Mm-hmm.
Yeah.
Okay, good. So we're going to talk about this a little bit more. We're going to go to a whiteboard because, you know, the lecture is good, but it doesn't give you enough information. So I need to give you the gold here. You want the Cadillac, not the Pinto, right? Okay, nobody got my car joke? Okay, I give up.
I don't know what a Pinto is.
The Ford Pinto.
A Ford Pinto. Look it up on Google. You can find everything on Google these days.
A
I'm not gonna
Pinto
tell
with
you.
P, like a pinto bean?
Yeah, it's
Yeah.
like a Pinto bean. Yes.
One of the worst cars made in America.
Okay. So on the board, I have a couple of numbers. We're going to go through Sig Figs real quick. So as I told you, we try to figure out the number of significant figures. So the way that we figure out numbers of significant figures, zeros aren't going to be considered significant unless they're in certain situations. So for instance, trailing zeros, this is an example of trailing zeros, right? They're not considered significant. So in this case, only numbers other than 0 are going to be considered significant. So then how many significant figures do we have here?
One.
One.
Okay, so we have one Sig Fig. Oops. Okay, now if the 0 is captured in between two numbers, it's considered significant. So if it's stuck between two numbers, or if it's stuck between a decimal, it's considered significant, okay? So here, how many significant figures do we have here?
3.
3.
What about here?
4.
4.
Okay, so under circumstances where we have a decimal and then we have zeros following it, these zeros become significant because you're letting the other person, the person that you're sending the data to, know that, hey, my scale was really good and I know that this number is really exact and it's really a 0, okay? So then how many significant figures do I have here?
5.
5.
So these are leading zeros. So these zeros, like above, these zeros are really space holders. They're just to let me know that I have a really, really, really small number, right? But they're not considered to be significant. Okay, so then how many significant figures do I have here?
2.
What about here?
3.
3.
3.
And here?
2.
2.
Simple?
Yes.
Yeah.
Mm.
Yeah.
Okay. Now, I'm going to type up some more numbers here. Let's say that I asked you to give me 3 significant figures for this number, the very first number. I want 3 Sig Figs. Now, 5 is that funny number, right? So we use 5 as our median point, right? Because if it's less than 5, then we're going to keep that number, the number before it or in front of it, the same. So what I mean here, 3 Sig Figs. So we're going to be looking at the 5 that I have circled here, right? or that number that we have circled there. Now, if that number is 5 and greater, or I should say, if it's greater than 5, then we're going to round up. If it's less than 5, we're going to leave it alone. We're going to just put a 0 there, okay? If it's at 5, it depends on the number that's trailing it, okay? So if there's a number after it, then we round up. If it's just as 5, and then there's a 0 after it, then we actually will just put a 0 for that number, okay? You guys understand what I'm saying?
Yes.
Okay, so let's see if we can do this. So 3 significant figures. So what would be the number now?
126.
126.
126.
Is it 126?
0.
Okay. Now don't forget
Because you have to hold them.
don't forget your placeholders, right? Because if you earned $12,000, right? $12,600, $12,556, and I gave you $126, what would you do to me?
Beat you up. I'm
You'd probably
kidding.
beat me up, right? You would want to fight. You'd be like, wait a minute, hold on, I did all of that work and you're only paying me this. No, that does not work, right? You get upset with me, right? So think of it as money, right? Always remember your placeholders, okay? That's going to be essential. That is the biggest mistake that young chemists make when they're learning Sig Figs, okay? And is the biggest mistake I see on exams, okay? Simple. And
Yes.
think about money, right? Because you're not going to cheat yourself. Now, if you do, you're an idiot, and there's nothing I can do for you then, right? Okay, so what about this number here? 3 Sig Figs.
You're going to round it to 3 again?
I'm going to round it to 3.
The
What
same
will be the number? Yeah,
It's
3
the
Sig
same
Figs.
exact as the first one.
Same exact number as the first one.
Yeah.
Okay, what about the one below it?
The same.
The same 126.
Actually, no.
No,
Oh.
because the 5 has a 0 after it. So it'd be 125, 0, 0.
Oh.
Okay, what about the one below it?
126.
0.
Yeah, don't forget the 0, 0. And then what if I had this one? I forgot to add the last one.
$125, 0.
Okay, simple.
So Dr. Henry, why would the third one, the 125.50, why would that stay 125?
Because we look at the 5, right? It's right at that midpoint. So since it's right at the midpoint and you don't have any numbers trailing it, it's going to be at 5. Now, this does not work in the real world, because in the real world, somebody would hurt you over $50, right? I don't know about you, $50 is, I could buy my girlfriend a dinner and my other girlfriend a dinner at McDonald's maybe, but so.
Like a Taco Bell or something.
Exactly.
Taco Tuesday.
I give them 11, that helps with the meal there. Okay, so in that case, because you're at 5, in science, technically you're supposed to look at that number and you look to see if there's anything following it. If there's nothing following it, you just drop it down. Okay, so you make it that 0 instead of rounding it up. Okay, this case, we had that 0.1, so that pushes it over, and so we're going to round it up. You see the difference?
Yeah.
Okay. And believe me, I fought my teacher on that point forever, because I think about money, right? $50 can go a little bit of ways. You know, if we're talking about like a 10 cent or something like that, I may be, you know, hey, okay, I can go with that, right? But $50, I'm gonna fight you over it, you know? So for instance, let's say I have this number, start simple. Okay, so what you're gonna do is, the guy that's gonna be the biggest number and the least significant is typically the one that's gonna win. The way I establish this is by drawing lines. It helps me to visualize it, and I know this is the old way of doing math, but we're gonna do it the old way because I'm old. So I go through and I find where the significance ends. Like for instance, this number here, the significance end at the 9. So all three numbers are significant. So this is where significance is going to end. What about the number above it? The 370. Where's significance? Which numbers are going to be significant?
3 and 7.
3 and 7. So I'm going to draw a line between the 0 and the 7. I know my line looks like it's been drinking. Okay, now what about the very first number?
After the 5.
Okay. So between the 5 and the 0. Okay, so which numbers are going to be significant? Which line is going to be the line where I decide significance? The orange line, the green line, or the blue line?
Wouldn't it be the green line?
Nope.
No.
The blue line?
The blue
Nope.
line.
The blue line.
Nope.
Orange
Those
line?
numbers are big.
Orange line?
It is the orange line. Because the numbers here, right, they're not going to be significant, right? Look at it. It's 12,500. Is $3 really going to make a difference to you?
370.
Are you really that concerned about that $3? Are you concerned about, is that $3.59 going to make a difference compared to that $1,500?
That $370 is.
Well, of course it is, but that's why the $3 isn't, right? So
Yeah, but what about the 70 and the second one?
just wait there. Maddie, just relax. Bear with me for a second. But the point is, you're going to be more concerned about that bigger number, right? Than you're going to be concerned about those really small numbers, right?
Yeah.
Relative to each other, are you more concerned about it getting $3.59? Or are you more concerned about that you're getting $12,500? Which one? Maddie?
12,000.
I'd be okay if you skipped out on me on that $3, right? $3.59. I would be pissed off if you only gave me $3.59, and I'm really worried about that 12,000, right? So this line here tells me that my significance is here. These numbers, they're uncertain, but we're going to go ahead and add them up. So we have, if we add up, is that correct? Okay, so we use this number here to determine whether we're going to round up or whether we're going to round down. So Maddie, we're not forgetting about them completely. We have to take them in consideration, but you use the number that's between the number of significance and the numbers that are no longer significant. Okay,
So we'd round up to the 129.
so it'll be, is it going to be 129 or is it going to be?
129.00.
Okay. And so your answer would be $12,900. Now, would you be happy with $12,900?
Yeah.
Okay. Make sense?
Yes.
Okay. So let's say we have this number. So where am I going to draw the line? So let's talk about
After
that first number.
The 3.
You said after the 3?
Are you talking about the first number only?
Yeah, let's start with the first number. Let's do them individually.
After the 7.
The second number?
After the same. And the third number is after the 3.
The last number?
After the 1.
Okay, so which number, where am I going to draw my significance?
With the purple?
The purple, this one here?
The pink. The like that
The
first
pink.
one.
Oh,
The
pink.
first one.
The magenta color.
That
Yeah.
one. That one?
Yeah.
Okay. Okay, so then let's go ahead and do our Okay, so then what would be my number? The final answer?
003. 0.003.
Because we use this to round. So we're rounding, we're not going to round up, are we?
No.
No.
Okay. Piece of cake?
No.
What,
I feel
what do you
like
want me to, what is it hard about it, Maddie?
Just figuring out where the line goes. That one was easy because the numbers were so small, but when they're bigger, I get confused. But I'll just go into like your office hours or something.
Okay.
Isn't it the least amount of decimal points?
Or the least amount of sig figs, right? That's how many sig figs we should have at the end.
Well, it's not necessarily the least amount of sig figs because we could have a number like this. Well, let's see. That's a, we could have a number like this, let's say.
Oh, because you can have 4 sig figs, and then the other, like another number can have 6 sig figs, and then the other one can have 7 sig figs, but it will technically only be 4 sig figs, right? Because you can't have more than the least amount of sig figs.
You can't have more than the least amount. Okay, so let's.
I'm probably wording it different, but that's just how I know. Like, you can't have like, I don't know.
I'll have to think about your wording, but it's not based upon that. When we were talking about multiplication, it's going to be based upon the number of sig figs. Here, it's based upon where those sig figs in, right? So like here, you have 3 sig figs here. You're drawing a line between it. Here, this one has 2 sig figs, right? We draw that line there, but we know that it's based upon this very first one because this guy has a larger number of uncertainty associated with it. Okay? So like for instance, let me give you extreme situation. Do one more since I just want to make sure that you guys got this and then we'll move on. We're definitely going to finish this chapter and then we'll does not want to erase. Clear. Okay, so let's say we have Okay, we're doing subtraction. Okay, so where am I going to draw my lines?
After the 12.
And then the second number?
After the 9.
Okay, which one are we going to use?
The pink.
Okay, so then this answer is going to be
What?
oops,
So
sorry.
what?
Oh, we're
We're
subtracting.
subtracting.
Yes, I forgot. That's 9.
Oh, okay.
Yes, subtraction.
Oh, okay. Because I was like, I'm lost.
Okay, so what number am I going to use to determine the number of significance?
9.
Which 9?
First 9.
The first 9.
Okay, so we're going to use this guy, right? So then my answer is going to be,
12.
12.
is it just going to be 12?
12, 0, 0, 0.
Okay, don't forget your space holders. Okay, how many sig figs is that?
2.
Okay, so Nadia, is that the least number of sig figs if you looked at the two numbers? Because if you looked at this first number, how many sig figs does this one have?
Wait, are you saying Nadia or Nadine?
Oh, I'm sorry, Nadine. Sorry, not Nadia.
Oh.
Nadine. Yes, Nadine. I'm just making names up, you know. I saw the N and an A, so.
No, but it is the first two sig figs that count. I think that's what I mean. So my first one was 3 sig figs, so I know that I'm gonna have 3 sig figs that are actually like, you know, that count. But then the zeros are added after.
Okay. So, and then at the end of the day, how many sig figs did we end up with?
2.
2. Okay.
And there's 2 sig figs at the top that actually, like, they were like the first 2 sig figs of the first number.
Yeah.
Mhm.
Okay. Piece of cake. Simple.
Yes, that one, yes.
Yeah. Okay. So now let's talk about multiplication and division. So with multiplication and division, it's pretty simple. It's just the number that has the least number of sig figs, okay? So how many sig figs does this guy have?
3.
3.
How many sig figs does this guy have?
2.
2.
2. Because that decimal means that 0 is going to count. Right? So then my answer is going to be what's my answer? Well, we'll do the multiplication and then we'll decide. What was it?
124.0.
Is it 124.0?
Oh, sorry. I didn't see the multiplication. I'm driving. Sorry.
That's right. So what is the answer?
123.0. Shouldn't it be?
Is it 123?
123.0.
Is it 123.0? Which one has the least number of significant figures?
2.
2. So I should have 2 significant figures.
Wouldn't it be just 123?
Is 123
That would
2
be
significant
three.
figures?
12.
120.
120.
It'd be
120.
Okay. So then you want to just, you use the number of significant figures, the one that has the least number of significant figures, and it's only with multiplication and division. Least number of significant figures. So the answer would be 120. Okay, you want to try again?
Yes.
Okay.
That was the most basic and most confusing Sig Fig I've ever had to look at.
Okay. Okay, so the first number, how many sig figs do I have?
3.
3.
The second number,
3.
the third number.
1.
1.
Okay, what is the lowest number of sig figs?
1.
1.
1.
Okay, so my answer should have how many sig figs?
1.
1.
Okay, so if we do this, so this would be the answer, not taking into consideration sig figs. So what would be the answer when I take sig figs into consideration?
25,000
No, that'd be
25,000?
or
20,000.
20,000.
Simple?
I'm confused. Why would it turn into 20,000?
Oh, that's the same question I was going to ask.
Because I know
Because
I can
there's-
multiply it, but I don't get why it turns into 20,000.
Because we take the one that has the least number of significant figures. 2 is only one sig fig. So
Okay.
our answer is only going to have one sig fig. These guys
Oh,
have
so
3
the first
sig,
number.
Yep.
Oh.
which is only, so here, this only has one sig fig. Simple?
I
Yes.
get you.
So Dr. Henry, so why wouldn't it be 25?
Because that would be 2.
2, yeah. Okay, yeah. That makes sense.
Want to do one more, just for good measures?
Yeah.
Yes.
Yeah.
Yeah.
That's supposed to be 0.00. Okay. I'm writing it down, that's why.
Actually, we'll make it a little more challenging. It's too easy.
That was kind of.
No, not too easy.
Oh my
Love that.
god. You didn't even teach us division yet.
It's the same as multiplication.
Oh, okay.
I told you that, multiplication and division. Okay, so let's work through this. How many sig figs do we have for the first number?
4.
4.
3.
Correct answer is 4. Remember, if it has a decimal, that means I'm so good that I know that that number is 0. Okay? What about here?
2.
And then here?
3.
3.
Okay, which one is smaller? 4, 2, or 3?
2.
So this is how many sig figs we're going to end up with at the end.
2.
Okay, so our answer is going to be, what is it?
Isn't it 0.0414?
I'm getting there. I'm not done yet. I'm doing this in my head. Actually, it's 0.0, right?
Yeah.
Make sure.
There should only be 2 zeros. There you go.
Okay, so how many sig figs am I going to have at the end?
2.
2.
So then my answer should be
0.0410 or 41, maybe.
0.041.
that is correct.
Got it.
Okay, piece of cake.
Yes.
Yeah.
So any numbers after the decimal are considered significant, like the zeros?
So any number after the decimal, right? Not
Yeah.
any number after the decimal. These numbers here, they're questionable, right? You're not sure about them. So you're not taking them into consideration. So you're going to use this as a rounding number. So use that 4 to determine, are you going to round up or are you going to round down?
Okay.
Round up or leave alone. Okay.
Okay.
Okay. Simple.
Wait, I have a question.
Yes.
So you know how you said that we use the 4 to maybe round up or round down?
Mhm. I mean,
Why
round
didn't-
up or leave alone. Let me
Oh
correct.
yeah.
Yes.
Why didn't it become 0.040? Oh, because we leave it alone, huh?
That's correct.
Oh, okay, okay.
Yep.
That's right.
Okay. Any other questions?
Wait, so you only leave it alone when you're multiplying and dividing? And things, or?
No. We did the same thing when we were doing addition and subtraction. Once we found that line, right, we took that number that's next to it, we use that, and if it, as I said, if it's above 5, we round up. If it's 5 exactly or below 5, then we make it a 0, right?
So if that was a 6, if that 4 was a 6, it would be 0.042. Is that what you're saying?
That's correct.
Okay.
Okay, questions? Concerns? Okay. So if you do PEMDAS, and if you do PEMDAS, then do you guys know what PEMDAS is?
Yeah.
The little parentheses, I can't remember what it all stands for, but ultimately the same thing. If you have addition and subtraction, multiplication is always gonna come first, right? So you're gonna do multiplication, then you're gonna do your addition and subtraction. And so you wanna obey the rules at each step. So if you're doing the multiplication, take care of the multiplication first. Find the number of significant figures, okay? And I'll give you an example of that here in a second, okay? So let's work through this. So when we're under these circumstances, this should be parentheses, sorry. You want to do the multiplication here first, that's in the parentheses. So parentheses, and then you want to do your multiplication and division, okay? So what is the answer that you guys get? How many sig figs do we have here? First off, for the first number.
3.
3.
3.
For the second number.
2.
And for the third number.
1.
1.
Okay. So your answer in the parentheses is going to give us how many sig figs?
1.
1.
Okay. Okay, so we have 1. Okay, so let's go ahead and do the math here. What did you guys get?
271,000.
Okay, so then the answer would be, if I had 1 sig fig, would be what?
28, or no, 300,000.
3.
3, yeah. 30.
0, 0. Wait, how many?
Did I have to
are
make
there?
two little
yeah,
zeros?
7 is bigger. Yeah.
So hold on, make sure. The 200.
0, 0.
Got 1 0. Okay. And then if I'm subtracting, where am I going to draw my line?
The 2, the first 2.
Oh, this guy's no longer here, sorry.
Oh.
He's up, round up here, sorry. My bad.
The 3.
At the 3. Okay. Okay. And what about the second number?
After the 2.
So the 2,
Okay, so which one am I going to use?
the first one, the after the 3.
First one. Okay.
You would use the first one because it's a higher level of uncertainty, right?
That's right. And so my answer is going to be, the real answer is going to be 2, 9, 8, 8. Okay, so what number am I going to use to round?
The 9.
I'm going to use the 9. So my answer is going to be
3.
3.
0, 0, 0. All the same numbers.
piece of cake.
Yes.
Yeah.
Okay, that's it. That's all. That's all I wrote. Okay, let's move on. Ready to move on?
Yeah.
Okay, so what happens when we have scientific notation in terms of multiplication? We have this going on. So how many sig figs is this?
3.
It's 3 sig figs because you use this number to determine your sig figs. This is kind of an exact number, so you don't have to worry about that part of it. You're sure about that, okay? So if I have this happening, how many sig figs will my answer have?
2.
And the answer is going to be
2 sig figs.
it's going to be 2 sig figs. So the answer is going to be 3.2 times what?
Ten to the third power? Oh, 6 power. Okay.
Why is it 6?
Because you're dividing this number here, right? So if I divided this number, that's 10 to the minus 3, right? Division means that subtraction now is a minus minus. So what is a minus minus? A minus minus 3. What would that be? Let me write that down so you guys can see it.
Like -3 minus 3?
So if you have this going on, what does that mean?
It becomes a positive.
Positive.
It becomes a positive, okay? Because that, the division means that for exponents, putting a minus there, okay? So then it becomes 6. So it's 3 plus 3 for exponents. Okay, piece of cake.
Yeah, so far, yes.
Okay, good. So let's go back to the lecture. Okay, so this basically, in the notes, we talk about the uncertainty. I've talked about your leading and your trailing zeros. So, and this is just an example to kind of help explain it. This gives you the rules. This helps you understand when you're rounding up. Okay, so now let's talk about accuracy and precision. Okay, accuracy means that you're hitting the target, right? You're hitting what the target is. Precision means that you're constantly hitting that target, like, or your numbers are constantly the same. Let's say you may not hit the target, but you're hitting in the same area. Like, so this first one is accurate and precise. It's hitting the target and all your things are in that area. This guy here is just precise. It's not accurate because you're not hitting the bullseye, but you're consistent. You're very consistent where you're at. And then this guy is neither not accurate or precise because your targets are all, well, they're not all over the place, but they're not close enough together to say that it's precise. Do you guys see that?
Yes.
Yeah, no, maybe.
Yes.
Okay. So this very first set of numbers, is it accurate or precise? So our goal is we're making cough medicine and we're trying to get 296 milliliters dispensed every time. So is it accurate? Looking at the number?
No.
No.
No. Is
Precise.
it precise?
Yes.
Yes.
Okay. What about the middle one? Is it accurate?
No.
No.
More so than the first.
It's more accurate. It's not 296, but it's at least in the 290s, right? And if you take the average, it's about going to be 296-ish, right? Is it precise? Or is it kind of?
No.
So it's not precise. Now, what about this last one? Is it accurate?
Yes.
Yeah.
Is it precise?
Yeah.
Yes.
Okay. Piece of cake?
Yes.
I guess it also helped
Yeah.
that the answers are at the bottom, right?
Yep.
Okay. So the next thing that we want to do is talk about how to treat numbers. So dimensional analysis, we basically use dimensional analysis. We've done examples of it already, right? You guys are familiar with dimensional analysis. You're also familiar with conversion factors, right? So how many days are in a year?
365.
So there's 365 days in a year. That's considered to be a conversion factor, right? So if I wanted to change, if I told you that I'm fasting for,
A month.
okay, I was gonna say, I'm fasting for 4 years, right? I'd probably die, but if I said I fasted for 4 years, first off, you'd call me a liar. But can you tell me how many days I fasted for?
Yeah.
Yeah, you could do that, right? So we would just use our conversion factor. So I said I fasted for 4 years, right? So we would just simply use our conversion factor. How many days again?
365. Multiply that by 4.
So we know that 1 year is 365 days. And we want to be sure to include our units, because I don't know what you're talking about otherwise.
Four.
Okay, so the concept of tracking our units, that's called dimensional analysis. It helps us make sure that our answer is correct. I strongly recommend you do it. Do you have to do it? You're grown. You can do whatever you want to do. Can you do me a favor? One of you guys, you're getting feedback from me talking. Can you mute yourself? Okay, thank you. So again, we're going to use conversion factors. The thing about conversion factors, we can flip them the way that we want to for our benefit. And this is just basically saying that. 3 different ways of saying exactly the same thing. 2.554 centimeters is equal to 1 inch. We could sit there and put them over each other, 2.54 centimeters over 1 inch. Or we can go 1 inch over 2.54 centimeters. It means exactly the same thing. But we're going to use them under different circumstances. If we're starting off with inches and we want to convert it to centimeters, we're going to use this guy. If we're starting off with centimeters and we want to convert to inches, we're going to use it in this fashion. Okay? Simple? Thumbs up. Just give me a thumbs up reactions when you get it, since we have everybody muted. Okay? Good. These are some of the most common conversion factors. You will have a conversion sheet because I don't believe in making you memorizing it. I believe in making you know it. You're going to get so many problems that you're going to be vomiting conversion factors. If you can't tell from the first homework assignment. Have you looked at the first homework assignment?
Oh, yes.
Yeah, and the thing is that I was nice. I was like, okay, I'm going to trim down how many I actually have. Okay? And I did that. Okay. So instead of having, it was about 250 questions. I think I trimmed it down to like 85 or something like that.
Trimmed it down.
I trimmed it down, yes.
Mm-hmm.
Okay, so these, as I said, are some of your conversion factors. So you want to familiarize yourself with them. You want to be able to use them, and you want to be able to flip them back and forth. Make sure that you understand that. And you want to track your units. Okay? Questions, concerns, Cash?
Gosh.
I'm trying to make money here, you know? Teaching don't pay as much as people think it does. Okay, so again, this is an example. We've done an example already. Are you feeling confident with it?
Yes.
Have you started the homeworks?
Me? Yes.
Good. But don't wait till the last minute, because you wait till the last minute, you're getting burned. I promise you.
I just need 40 more.
Good. Okay, so temperature. Did we talk about Kelvin? You guys remember Kelvin?
Yes.
Yeah.
Okay, what is Kelvin?
Measures temperature.
Measures temperature. Okay, why do we use the Kelvin scale? What was the significance of using a Kelvin scale? Sure, I talked about it. What was it?
It's exact.
Because of fat?
It's exact.
It's exact? What do you mean by that?
I don't know, I just remember that. All sciences use Kelvin.
But why? What is the significance of the Kelvin scale? Why do we choose to use Kelvin rather than anything else?
Because maybe they wanted a temperature scale where 0 reflects like something normal with, how you say the word? The thermal energy thingy?
Nope.
No?
Is it
Nope.
because it's part of the metric system?
Nope.
I think it's because that there's like a certain temperature that, like, I can't remember. Hold on.
Because it's one of the ways that you can see the Fahrenheit thing.
Nope.
Is that how you even how you say it? Yeah.
Is it because there's no variability? Like Kelvin is exactly 0, where everything else is a different number?
What do you mean by that?
What?
That whole concept of exactly 0. I don't get that. I don't understand.
The freezing point.
Yeah, the
freezing and boiling.
And freezing
What
points.
do you mean by freezing? Wait. You're getting there. You're getting warmer. Getting warmer. Starting to get a little hot in here. So help me out here. What do you mean by that freezing point? What happens at K
Because
equals
that says
0?
0 K, that's when like life will stop, right? That's when it's like absolute 0.
Yes, absolute 0. Yes. Yes, that's the reason why we use the Kelvin scale, because we know that Kelvin.
Did I get ignored? So it is absolute 0, right?
It is absolute 0. Yes.
Oh my God. I've been doubting myself this whole time. Y'all just really went out there to ignore me.
Y'all were just throwing everything out though. I was like, man, this is interesting. So that's going to definitely be a test question.
No.
Yes.
Just write it down.
Okay, so we know that Kelvin is absolute 0, right? And so you need to be able to sit there and distinguish between all of the different temperatures, because we are in the US. In the US, what temperature do we use?
Fahrenheit.
We use Fahrenheit, right? We use Fahrenheit. Everybody else in the world uses Celsius, and only scientists use Kelvin, okay? So you're gonna have to be able to convert from all different types of temperatures. And there's equations to do that, okay? So we'll talk about those equations right now. So we know in the Celsius scale, water freezes at 0 degrees Celsius, water boils at 100 degrees Celsius. On the Fahrenheit scale, water freezes at 32 degrees Fahrenheit, and water boils at 212 degrees Fahrenheit. So if we sit there and do our math, right? We can set up an equation just in case we didn't know it already, or it's not written, it's not going to be written on your conversion sheet. Then we can sit there and say degrees Fahrenheit. Oops. I don't know why I put 5 there. Just thought 5 was a good number. So degrees Fahrenheit is equal to 9/5 degrees Celsius plus 32. Okay, so if we have 0 degrees, so 0 times 9/5, what is Fahrenheit?
What did you ask?
I said if I gave you the temperature, 0 degrees, the temperature that water freezes, so 0 times 9/5 is going to be what?
0.
0 plus 32?
32.
32. So then the temperature in Fahrenheit is 32, right? So if we have 100 here, 100 times 9/5,
212.
so it's 180 plus 32, 212. Does that work out right?
Mm-hmm.
Yeah.
So this is the equation from changing Celsius into Fahrenheit.
Wait, so technically 0 plus 0 is 64.
What do you mean by 0 plus 0 is
0,
64?
I don't know how to say it in English, so I'm just gonna say C. 0C plus 0C equals to 32F.
Okay, I'm a little confused as to what you're trying to say. No,
Never
so
mind,
you're
doesn't
putting in-
matter.
Yeah, so you're putting in the degrees in Celsius here. You're multiplying it times 9/5, and you're adding 32, right?
Yeah.
So then you're changing it to Fahrenheit, right? So then that means Fahrenheit is going to be 32 degrees, right? Make sense?
Yes.
Yeah.
Yeah.
So,
So-
that's why.
So you can replace the 9/5 with 1.8, right?
Yes, you can.
Okay.
Yeah, but I just happen to remember it this way, so that's why I couldn't remember the number. So. Okay, so I can actually change this equation around, right? So by doing a little bit of algebra, I can solve for C, right? So degree C is equal to Fahrenheit minus 32 divided by, times 9/5, or 5/9, sorry. So, and then I always like to check that out. So I'll put in 32. Well, 32 minus 32 is 0, times 5/9 is going to be 0. If I put in 112, that's going to give me 180 here, divided by 180 is going to equal 100. 180. 180 divided by 1.8 is going to equal 100. Okay? So piece of cake, and it's a good way of confirming, since I remember 32, water freezes at 32 degrees Fahrenheit. It boils at 212 Fahrenheit. And I also remember in terms of Celsius what it equals. So I was able to confirm that equation. Piece of cake? Yes, no, maybe?
Mm-hmm.
Okay, good. So, and we know earlier, based upon this, degrees Celsius plus 273 degrees Fahrenheit, 273 degrees, or 273.15 is going to equal Kelvin. And if I get really hard up and they're giving me in Fahrenheit, I can plug in this number here in for that C. Okay, so then I can say K is equal to 5/9 degrees F minus 32 plus 273.15. Okay? Then I can simplify it if I need to, but it's not necessary. Oops. Come on. There we go. Okay. So we, at the end of the day, you're going to be able to go between all three different possibilities without a problem, right? Yes, no, maybe? These are just those equations again, shown nicely. And this is just how they compare to each other. Okay? Questions, concerns, Cash?